Hi guys, welcome to my lab. So today we're going to do the paper chromatography experiment. The goal of this experiment is to observe how the method of chromatography can be used to separate the different chemical mixtures. Okay, so in our materials we have our 50 ml glass beaker, we have our 150 ml plastic beaker, and we also have our chromatograph paper right here. Then as our solutes, we have the bromophenol blue. It's a 0.04% aqueous solution. It's not clearing up. Okay, doesn't matter. So then we also have our copper nitrate, 0.1 molar solution. We have our food coloring right here. Then we have our it's right here. We have our black wet erase pen. So we have our mixed juice, and finally we have our blue sketch pen. Another solution that we're going to be using is our potassium iodide. It's a 0.1 molar solution. Then as our solvent, we're going to be using the distilled water. Then we have our reaction plate. It's 96 well. We have our cotton swabs right here, and we have this as our drying rack. Okay, so after all the spots have dried, the paper was rolled into a cylinder and the edges were taped. So now the cylindrical shaped paper has been placed with the pencil marks towards the bottom in a beaker containing the distilled water to a depth of about 3 millimeters. And the paper is kept in the middle so that it doesn't touch any of the edges of the beaker. Okay, so now in 20 minutes, we're gonna lift the paper from the beaker, the tape is removed, and the paper will be left to dry. So at the end, we will want to see the final chromatogram as our result. Okay, now the 20 minutes are up, and as you can see here, this is our final chromatogram that we got. But we're not fully finished yet, because the first one, for the first solution that we had, the copper is actually colorless. So in order to make it visible, we have to dab the potassium iodide onto it using our cotton swab right here. So I'll add some potassium iodide in here. Good. Now we'll take it and so as you can see, the copper ion is becoming visible. So the distance of the color streaks above each of the spots will now be measured from the line drawn by the pencil to the top of the color streak. So here you can see the copper. It's become visible. Copper ion is being visible. Okay, so now to our results. So the distance traveled by the substances are measured from the top of the color streak to vertically down on the start line that we marked with the pencil, 1 centimeter from the edge. On table 3.1, we see the distance traveled for the different components, and in table 3.2, we see the retention factor for these different solutes. And the retention factor is found by The equation retention factor is distance of solute divided by distance of solvent. So we can conclude that, so to sum up, as we observed that the chromatography is an analytical technique which is actually commonly used for separating a mixture of chemical substances into its individual components, and it is generally used to separate mixtures of soluble substances such as food colorings, inks, dyes, or plant pigments. So the real-world connection of chromatography is its wide application in the different fields, because chromatography is now widely used in forensic science, in pollution monitoring, and also for studying complex mixtures in such things as food, perfume, petrochemical, and pharmaceutical production. And one of chromatography's big advantages is that it works with very low concentration samples as well.